All right, I wanted to give you a kind of a quick introduction here to parallel circuits so you can knock out these parallel circuit problems. The first thing that I want to review was the rules for series circuits, and we'll compare those to parallel circuits. So if you have a series circuit, there's the four rules that you have to know. Voltage adds, current is the same, resistance adds, and power adds. Okay? If you have a parallel circuit, it's much the same, except voltage is the same, current adds, notice these two switch, resistance is you have to take the inverse or use the x to the -1 key, and then power adds. Okay, so they're very similar. This is power. So power is going to add in a parallel circuit just like it does in a series circuit. Resistance is going to add in a parallel circuit, but you've got to remember to use this x to the -1 key. Current adds, which is the opposite. These two are just switched. They're just the opposite, okay? So let's look at an example, and then I'll show you how to solve one of these, all right? So we'll add a new page. All right, so if you had a parallel circuit, and this is how it's different from a series circuit. You know, in a series circuit, there is maybe a couple of resistors, but there is only one path. Any electrons that leave the negative terminal here have to go through both resistors to get back to the positive. There is only one way, okay? Now, in a parallel circuit, that's not true. In a parallel circuit, you might still have two resistors, but you've got two paths. And if you look, you know, electrons can leave the negative and they can go back to the positive here, or they can leave the negative and they can go back to the positive over here. And that's what makes a parallel circuit different than a series circuit. Now, in this wire here, going back to the battery, and in this wire here, going back to the battery, it's really kind of like a series circuit. Those currents are going to be the same. But when it gets here, this is called a node, and at the node, the current is going to split or divide, and it's going to go both ways. And then up here at this node, we're going to see the current coming from this resistor, and they're going to run back together and go back to the battery. So this part of the circuit is called the main line. And these things over here where the resistors are called branches, kind of like a tree. This is like the trunk, and then the branches branch off of that and carry part of the load. And so each one of these passes a current, okay? Now, if you want to solve for the resistance in a parallel circuit, it's a little bit tricky. You know, in a series circuit, it's pretty simple. And I'm just going to use 1 ohm resistors here to make the math very simple. So 1 plus 1. Oops. Got ahead of myself. 1 plus 1 is equal to 2 ohms. And everybody can do that, just add up, right? But when you have a parallel circuit, when you have a parallel circuit, I'm going to flip this over here. Hang on just a second. So I think that button by accident. When you have a parallel circuit, it looks like this. And before you can add those resistors, you have to take the reciprocal. Well, what is the reciprocal? Well, the reciprocal is 1 over the number. So it's 1 over 1 ohm plus 1 over 1 ohm. So if we do that, okay, 1 over 1 plus 1 over 1, well, what is the reciprocal of 1? It's 1. But it's not an ohm anymore. It's a mho. And that's not the best mho symbol. Plus 1 mho. It's just ohms upside down. And that equals 2 mhos. But what do you do with a mho? Well, you want to get it back to ohms. So you take the reciprocal of the 2, and 1 over 2 is 0.5, or 1/2. And so the resistance of this circuit is 0.5 ohms. So even though you have 1 ohm up here, 1 plus 1 is 2, and down here, 1 plus 1 is 2, but it's 2 mhos, because you're taking the reciprocal, and then you got to flip it upside down, and it's a 1/2 ohm. So you can see in a series circuit, resistance is going up. In a parallel circuit, resistance is going down. Okay? Now I'm going to switch over to the Google calculator, and I'm going to show you how to do a problem like this on the Google calculator. So bear with me. I'm going to have to switch over here, and I'm going to have to go to calculator. Okay? And the calculator's coming. There it is. All right, and so remember, whenever you use the calculator, raising something to the power of -1 is the same as taking the reciprocal. So we did that problem we just did. 1 xy -1 plus 1 xy -1, that's your reciprocal, equals 2, just like we had. This is where everybody gets confused. Xy -1. And that's going to give you your answer, 0.5. So you have to remember to take the reciprocal of the answer. Let's do another example. Let's say you had 220 ohm resistors as an example. 120 xy -1 plus 120 xy -1 equals, and then just take your reciprocal, xy -1. And I messed something up there, so I'm going to do that one more time for you. 120 xy -1 plus 120 xy -1 equals, there we go, xy -1 equals 60, and that's the right answer. And you know that's right because whenever the resistors have the same value, if you remember, 120 divided by 2, because there's 2 of them, is 60. If they're the same value, you can take that shortcut, but most time you got to work it out on the calculator because they're not the same, and that's the way that you would do that. Okay, so let's go back and back over here, and we'll just look at an example problem that you might have to do. So I'm going to add a page, and we're going to put in a circuit here. And let's say that you had a 100 ohm resistor, a 200 ohm resistor, and you had 120 volts over here, and you want to solve it. So this is R1 and this is R2, and you're just going to make a table. E, I, R, R1, R2, total. All right, and so you're going to fill in your 120 volts. Now remember, in a parallel circuit, voltage is the same. So all of these are the same. You're going to fill in your resistors, 100 and 200. And now you got 3 things you got to find. Well, 4. You got to find this current, this current, this current, and the total resistance. And there's a couple ways to do that. But let's start by finding the currents. So that's going to be 120 divided by 100 and 120 divided by 200. So back to the calculator, and we've got 120 divided by 100, and that is 1.2. And so we'll go back to our table, and that's going to be 1.2, and then back to the calculator, and then we're going to have 120 divided by 200, and that's going to be 0.6. All right, so back over here, and that's 0.6 amps. But now remember, when you go to put that in on your table, that's going to have to be converted to milliamps, moving the decimal 3 places to the right. That's going to be looking for 600 mA. And we're going to add those together. 0.6 and 1.2 is 1.8 amps. Or you could do the 1 plus the 600, 1.2 plus the 600 milliamps, get the same thing, 1.8 amps. And that leaves us with finding this total resistance. Now, there's 2 ways you could do it. We know that R is equal to E over I. So that's 120 divided by 1.8. Or you could use your X negative 1 key. Everybody can do the division. I'm going to show you how to use the X negative 1 key one more time on the calculator. That's 100 and 200. So let's go back to the calculator. Let's clear it out. 100 xy negative 1 plus 200 xy negative 1 equals, and then xy negative 1 for the final answer is 66.6666. And you're going to run into this a lot in parallel circuits because you're going to have these 1/3 and 2/3 ratios, and it's going to be repeating decimals with 6s or repeating decimals with 3s. So what I would normally do is just say 66.7 and be done with it. So when you go back to your table, it is 66.7 ohms, okay? And that's the way that you would do that. Now, there's one last thing that I want to show you how to do. Let's say you had a problem like this. Let's say that you knew one resistor was 12 ohms. You did not know the value of the second resistor at all, but you knew that the total, or sometimes you'll see this REQ, that means equivalent. That's the same thing as total. You knew the equivalent resistance was supposed to be, 4 ohms. What is the value of this unknown resistor? Well, it's very simple. You're going to subtract instead of add. So it's going to be 4 x to the negative 1, subtract 12 x to the negative 1, and that's going to be your answer. Okay? So I'll show you that on the calculator here in just. All right, so again, if you want to solve this, you've got to subtract, and you've got to subtract using the total number, which is counterintuitive because that's the smaller number. And we don't usually subtract the bigger number from the smaller number, but in this case you do because you're trying to work with reciprocals. So it's going to be 4 to the negative 1 minus 12 to the negative 1. Let's look at that on the calculator real quick. Okay, clear this out. 4 to the negative 1 minus 12 to the negative 1 equals, and again, you got to take the reciprocal of that answer to get your final answer, and it's 6. And that means that that missing resistor in that problem over here is 6 ohms, which makes sense because remember the resistance goes down in parallel. You've got a 12 and a 6, and the total is going to be less than the smallest. It's going to be less than that 6, and that's how you get the 4. And that should help you solve these problems. If you have any trouble, just let me know. Talk to you later. Bye.